Hello, my name is Ty Pohlmann. This is my term project. It is on life expectancy. A little bit about me. I am a senior graduating this semester. Throughout my career at UNLV, I was on the UNLV baseball team. At some point in the future, I do plan on going to grad school, but I don't have a very specific plan on what I want to do at grad school. And in addition to that, I don't have exactly the career field that I want to go in yet, but I do plan on going to grad school. My term question is, what are the factors that cause life expectancy to rise? Throughout the rest of this presentation, I'll kind of discuss my model, the descriptive statistics that go along with it, those including the mean, standard deviation, the minimum, the maximum. The next session will go over the correlation coefficients between the dependent and independent variables. Then we'll transition into the empirical results, and then the final thing we'll go over is the policy recommendations to government officials to make changes to their laws in order to maximize their population's life expectancy. So again, the purpose of this project is to determine what factors affect life expectancy. In addition to that, we're going to determine how much those certain factors affect the life expectancy, if that's positive correlation or negative correlation. And then the regression coefficient's also going to go over how to the magnitude of how those factors affect life expectancy. And then finally, we're going to go over the data and then give recommendations for policy decisions. The data source we're going to be using today comes from the World Health Organization, is found on Kaggle. The data is many data points from the years 2000 and 2015. There was a countless amount of variables in the data source. I narrowed those variables down to 5 independent variables, 6 if you include dependent variable of life expectancy. And those variables will help us conclude what affects life expectancy to rise. Here's the model with the dependent and independent variables. Life expectancy, that will be our dependent variable. Obviously, the sign is not applicable. The independent variables, infant deaths. This is just the number of infant deaths a country has in a certain year. The expectant sign with life expectancy is negative. Obviously, if we expect a country to have more infant deaths, we expect the life expectancy of that country to go down. The second independent variable is health expenditure. This variable is the percent of GDP spent on healthcare. We expect this sign to be positive. Obviously, if a country spends more on healthcare, we expect the constituents to get better healthcare and therefore rise their life expectancy. The next independent variable is BMI. This is the average BMI of a country. Typically, BMI, a lower BMI is associated to be healthier. So this is why we expect the sign to be negative. As the country's BMI goes down, we expect their life expectancy to go up. The next definition is GDP. This is the variable discussing the gross domestic product per capita. Obviously, if a country has more money, we expect their healthcare coverage to rise. And then finally, schooling. This is just the average number of years a person in their country goes to school. We expect this sign to be positive as more people go to school and get more schooling, we expect them to have better health care. This slide goes over the descriptive results. There was about 2,482 observations in the data source. The life expectancy mean is 69.388. This means that throughout the model, the average life expectancy basically in the world is 69 years. The standard deviation is 9.637. The minimum life expectancy is 36.3, and the maximum is 89. Infant deaths is the next variable discussed. The average infant deaths in the model is 31.24. Standard deviation is 126.61. The minimum infant deaths in the model is 0, and the maximum was 1,800. Health expenditure is the next variable. The mean health expenditure in the model was 872. It means 872% of their GDP. The standard deviation is 2,133. The minimum was 0, and the maximum was 19,479.91. BMI is the next variable. Its mean was 38.44, so that means the average BMI in the model was 38.44. Standard deviation was 19.97. The minimum was 1.4, and the maximum was 87.3. GDP was the next variable. That mean was 7,491. Standard deviation was 14,276. The minimum GDP per capita in the model was 1.68, and the maximum was 119,172.7. Schooling is the last variable. It had a mean of 12.08. That means the average number of schooling in every country in the model was 12 years. The standard deviation was 3.39. The minimum was 0, and the maximum was 20.7. The next slide goes over the correlation coefficients. The first correlation coefficient is between life expectancy and infant deaths. That correlation coefficient is negative 0.184. This just means that the correlation between infant deaths and life expectancy has a weak negative correlation. The next correlation coefficient is health expenditure with life expectancy. That correlation coefficient is 0.4069. This is just a moderate positive correlation. BMI is 0.5782, which is this is a strong positive correlation coefficient. This kind of goes against our prediction that BMI is going to have a negative correlation. This could be due to a number of factors, mostly that countries who have a higher BMI might have a higher GDP per capita. They might have more access to food. If they have a higher GDP per capita and more access to food, they probably also have more access to healthcare. That kind of why I can explain why there's a positive correlation between the BMI and life expectancy. The next variable is GDP. This has a correlation coefficient of 0.4599. This is, again, a moderate positive correlation. And finally, the largest correlation coefficient is schooling. Schooling has a 0.7545 correlation coefficient with life expectancy. This is the strongest correlation coefficient in the model, showing a strong positive correlation between the two variables. These are the 5 scatter plots between all the independent variables and the dependent variable. As you can see, infant deaths has a weak negative correlation. This correlates with our correlation coefficient presented in the previous slide. And the middle top scatter plot that shows the health expenditure and life expectancy. This shows a moderate positive correlation between the two variables, which does coincide with our correlation coefficient. BMI is the next scatter plot. This one has a strong positive correlation coefficient that coincides with the correlation coefficient previously. The next one is GDP and life expectancy. This shows moderate positive correlation. And then the final one is schooling and life expectancy. They show a strong positive correlation, obviously the strongest correlation between all the variables. All these scatter plots coincide with their correlation coefficients presented in the previous slide. This next slide is empirical results. So the regression coefficient for infant death and life expectancy is negative 0.000227. So basically what this means is for every increased infant death, it decreases the life expectancy by 0.000227 years. This is significant at no levels of P. And as you can see, it's very, very, for every infant death, it decreases the life expectancy of the country by not a lot. The next one is health expenditure. This one actually is negative compared to negative regression coefficient compared to the positive correlation coefficient. This one is 0.0000546, significant at no levels. Basically what this means is if the health expenditure goes up by 1, the life expectancy decreases by that amount, which is very, very insignificant. The next variable is BMI. Its regression coefficient is 0.101. This is significant at all levels. This coefficient means that the life expectancy decreases by increases by 0.101 if the BMI goes up by 1. GDP regression coefficient is 0.0000931, significant at all levels, meaning that if the GDP goes up by 1, life expectancy goes up by that number. The schooling regression coefficient is 1.658. This is significant at all levels, meaning that if the average number of years schooling in the country goes up by 1, the life expectancy increases by 1.658 years. This is obviously the biggest. This schooling has the most impact on life expectancy in the model. The R squared of the model is 0.6164. Basically, what this means is that 61.64% of the variation in the model is described by the variables. And then finally, the number of observations in the model is 2,458. Policy recommendations based on the empirical results. Obviously, schooling had the biggest impact. Its regression coefficient was 1.658. Although other variables were significant at all levels and had a positive coefficient, the coefficients were super small. So even increasing the certain variables by 1 had almost little to no effect on life expectancy. Schooling was the only one that had a major effect. By increasing 1 year of schooling, you increase the life expectancy by 1.658. So the policy recommendation would be to increase education funding in the country. This would have the biggest and fastest impact on life expectancy. Conclusions, like I said before, the 3 positive regression coefficients for BMI, GDP, and schooling, but obviously schooling had the biggest impact. So the policy recommendation would be to increase funding for more longevity in the population. The country can do this by many things, maybe free primary and secondary education or grants for college or something like that could possibly pay off in the long run and increase that country's life expectancy. I want to thank you very much for listening to my presentation on life expectancy and hope you have a great day.